Hello friends, in last class we discussed about the IUPAC nomenclature of alkanes. We discussed about IUPAC nomenclature of alkanes, and in that class we discussed about the rules. We discussed about the rules of IUPAC nomenclature of alkanes. Let me rewind that because today's class is totally based on these rules. The first rule was selection of longest chain. The first rule was selection of longest chain, according to which the chain which has more number of carbon, highest number of carbon, is selected as longest chain. That means main chain. Okay. The second rule was if two or more chains having same number of carbon atoms are present, then the chain which has more substance is selected as main chain. Okay. The third one was the numbering of chain is done from that side from which the substituent get minimum number. The substituent get minimum number. That means the carbon in which the substituent is bonded gets minimum number. That was our third rule. Okay. The fourth rule was in the naming of substituent we have to write the name of substituent first and then the name of main chain. Okay. And one rule was that in naming and numbering, if the substituents are different, then their alphabetical order is considered. Got it? And after that, in naming we write that the name of the name of substituent with their position right first, and then we write the name of main chain. Got it? One rule was that if the substituents are more than one, then di, tri, tetra, etc. are used. Okay, clear? Like this, there are two methyl groups, so that is dimethyl. There are three methyl groups, so that is trimethyl. And here that is two, that is di. Here again there is three, that is tri. Okay. And after that, the last one was in writing the name of organic compound, comma is used between the two numericals and hyphen is used between numerical and alphabet. Got it? These rules, so mainly that are 6 or 7 rules, which are used in the nomenclature of alkanes. Okay. If that point is not clear in your mind, then please just watch the video just before it. Okay. Now let me start the nomenclature. Now we consider some examples to more understand about these principles or these rules of nomenclature. Now the first one is CH3 CH2 CH3. Here if we consider the main chain, then it is 1 2 3 carbon. You can start from that side also because there is no substituent, so it is a simple chain, and in the case of simple chain we can start from any side. Okay, so that is the main chain. Here no substituent is present, so there is no need of indication of that, so we directly write the name of main chain. Since there is 3 carbon, so name is prop. Single bonded, then alkane, that is ane, so that is name is propane. Similarly here there are 4 carbon atoms and no other substituent, so that is main chain. Only main chain is present here, and we can write the number 1 2 3 4. because both sides are same. So we can start from any side. Now 4 carbon, that means bute. Single bonded, that means 8. So name becomes butane. Now here there is a chain of 3 carbon. In molecule there are 4 carbon, but the connectivity, line to line connection, that is 3. 1, 2 and 3. So that is main chain, and that is substituent. Okay, now numbering from that side or from that side, this carbon in which the substituent is attached get second number. So there is, we can select any side. Suppose we selected that one, so that is 1, 2, 3. Substituent is CS3, and you know that when CS3 is substituent, then it is known as methyl. That is methyl. On which carbon it is attached? Second. So its name is 2-methyl. 2 hyphen methyl. Hyphen, there is no need to speak use hyphen word in speaking, but in writing we use that. So that is 2-methyl. It is 2-methyl. Now write the name of main chain. 3 carbon, prop, single bond, ane. So that is propane. Propane is the name of main chain and methyl is the name of substituent. Got it? Since it is attached at the second number, so the name becomes 2-methyl propane. Got it? Now let me consider the next example. Here there is 1, 2, 3, 4, 5. 5 carbons are attached in a series. Continuously they are bonded with each other. So the main chain becomes this. Since none of the other group or atom is outside from this, so there is no substituent. So write the name of main chain. 5 carbon, pent, single bonded, ane. The name becomes pentane. Got it? Clear? Now our next example. Same 5 carbon atoms are attached like the 4 are in series. 4 are in series and 1 is in side chain. Since it is not included in the main chain, so it is substituent. It is substituent and its name is methyl. Okay, now write the number. If I start numbering from that side, then the substituent get second position, but if I start, then substituent get 1, 2, 3. From which side is getting minimum number? That one. So numbering will done from that side. 1, 2, 3 and 4. So the substituent is attached on the second number of carbon. Okay. So it is methyl attached at the second, so that is 2-methyl. Now write the main chain name. 4 carbon, bute, single bond, ane. So that is butane. If collect all of that, then the name becomes 2-methyl butane. 2-methyl butane. Got it? Now our next example. Here 3 carbons are in series and 2 methyl groups are on mid of the carbon. Here if we consider the main chain, then it is possible of 3 carbon. So that is and that is, these are substituents. Got it? Since 2 methyl groups are substituents, so the name becomes dimethyl. Di for 2 methyls. Now write their position. For that we done the numbering 1, 2 and 3. Since both of these are present on the second number, so the name becomes 2,2-dimethyl. Okay. Now main chain, prop, 3 carbon, that is prop, single bond ane, so name becomes propane of main chain. Now the complete name of that molecule, that is 2,2-dimethyl propane. Got it? Here there are two other names are also in bracket, that is isopentane for that and neopentane for that. These are their tribal names. These are tribal names of these molecules, and that is very important, because the paper setter can ask that write the IUPAC name of isopentane or neopentane. Isopentane or neopentane. So for that you have to know the structure of that. Got it? Now let me consider the next example. Here, that is the molecule in which 1 2 3 4 5 6 1 2 3 4 5 1 2 3 4 5 6, maximum possibility of chain, that is 6. Okay, so that is the main chain. Now let me do the numbering. It is ethyl, it is methyl. Since there are two different substances, and you know that if the substances are different, then we consider the alphabetical order. The order of if we consider that, then ethyl E, methyl M, which one comes first? E. So we have to give minimum number to this ethyl group. So for that the numbering will done from that side, because from that this group is getting number 3. If we done from that side, then 1 2 3 4, which one is less? 3. That's why the numbering is done from that side. Okay, so that is 1 2 3 4. Now write the name. It is ethyl, alphabetically E, so it will come first, that is ethyl. On which carbon it attached? Third, so that is 3 ethyl. Got it? Now the second substituent is methyl, so that is methyl. On which carbon it is attached? 4, so that is 4 methyl. Now main chain has 6 carbon, so for 6 hex, single bond ane, the name becomes hexane. Now if we combine all of that, then the name becomes 3-ethyl 4-methyl hexane. 3-ethyl 4-methyl hexane. Got it? Now let me consider that example. Here 5 sorry 5 carbon atoms are arranged in a chain, and 4 methyl groups are attached on the second and fourth. If we consider the main chain, then it is possible that is 5 carbon maximum came here. So now that is substituent, and that is also substituent. All 4 are same, that is methyl. So combinedly we can write that tetramethyl. Now their positions, 2 are on second number carbon and 2 are on fourth number carbon. So their indication will be 2, 2, 4, 4, 2, 2, 4, 4. Why? Because 2 are at second number, 2 are at fourth number. Their indications, tetramethyl because these are 4, and now main chain 5 pent, single bond ane, the name becomes pentane. So the complete name is 2244 tetramethyl pentane. Got it? Now our next example, this molecule. If we consider the chain, then 1 2 3 4 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. There is 5, maximum possibility of 5. But if we consider this one as main chain, this one as main chain, then only one substituent is attached. But if we select this one, then the substituents are two. One is that and one is that. And you know that, as we discussed, if the substituents, if the main chain has more substituents and same number of carbon atom, if there are two or more chains having same number of carbon atoms but different substituents, then the chain which has more substituents will select as main chain. That's why it is selected as main chain. Got it? Now, numbering. That is ethyl. Again, it is ethyl and it is methyl. So alphabetically E come first. So we have to give minimum number to ethyl. If we start the numbering from that side, then it will get 1, 2, 3. And if we start from that side, then it will get 1, 2, 3. Both sides it is getting 3. Now we consider the second substituent. If the first group which we have to give minimum number is getting same number, then we try to give minimum number to the second substituent also. If we start numbering from that, then methyl get fourth, but if we start from that, then methyl get second. So we start numbering from that side, because the first group which we have to give the minimum number comes same position in the both sides. So we try to give minimum number to the second substituent also. That's why the numbering is done from that side. So 1, 2, 3, 4, 5. Now write the name of substituent. Ethyl attached on the third carbon, so the name becomes 3-ethyl, 3-ethyl. Now write the second substituent name, methyl, on which is attached on the second number carbon, so the name becomes 2-methyl. So that is name is 3-ethyl 2-methyl. Now main chain 5 carbon, pent, single bond, ene, the name becomes pentane. Now collect all of that, so the name becomes 3-ethyl 2-methyl pentane. 3-ethyl 2-methyl pentane. Got it? Now the next example, this one. Here if we consider the chain, then there are various chains: 1, 2, 3, 4, 5 carbon chain, 1, 2, 3, 4, 5, 6, 7 carbon chain. Is there any possibility? 1, 2, 3, 4, 5, 6, again 6, 1, 2, 3, 4, 5, 6, 6. So there is one chain of 7 carbon and others are 6 carbon. So as we know, as per the rule, we have to select the longest chain. So that is longest chain, which is considered as main chain. Now that group is substituent, because it is not included in the main chain. That is also substituent and that is also substituent. Got it? Now since all of the three are same, all of the three, because these three are methyl groups, so we use trimethyl. Okay, now give the number. We have to give minimum number to the substituent. From if I start from that, then it will be 1, 2, 3, 4, 5, 6, 7. Methyl get 3. If we start from that, then 1, 2, 3. Methyl is also getting the 3. But if I start from there, then 1 is on third and remainings are on the fifth. But if I start from there, then 2 gets 3 and 1 get 5. So the minimum number, according to the minimum number concept, if I total the positions of the substance, then from that side the total is 3 plus 3 because 2 are at 3, 3 plus 3 plus 5. And if I start from that, then 1, 2, 3 plus 4, 5, 5, one more is 5. So the total becomes 11. Here the total becomes 13. So which one is less? That one. That is minimum. So the numbering is done according to this procedure. Got it? Clear? That's why numbering is done from that side. Now write the names. The position of the methyl groups is 2 are at third and 1 is at fifth. So that 3, 3, 5. Since all of these are methyl, so that is trimethyl. Got it? Now main chain 7 hept, single bond ane, heptane. So the total of that names becomes 3,3,5 trimethyl heptane. Got it? Now consider some more examples. That one. Here this is main chain and it is substrate. Give the minimum number to the substrate. If we start numbering from that, then 1 second. From that, 1 second third. So that is minimum number from that side. So the numbering done from that one. So that is chloro. Cl substrate is known as chloro. In the last class we discussed about it. So that is chloro. Which position it is attached? 2. So that is 2-chloro. Now write the name of main chain. 4 but single bond ane. So that is butane. Got it? So name becomes 2-chlorobutane. Its name becomes 2-chlorobutane. Got it? Now let me consider the next example. Here again the main chain is 4 carbon. Here that is chloro and that is methyl. Again the same rule. If there are different substances, then the substance which alphabetically comes first gets minimum number. That's why it is numbering is done from that side, because from that chloro C is getting minimum. Okay, now write the name of substance. That is chloro at 2 number carbon, so that is 2-chloro. Second is methyl at third number, that is 3-methyl. Now main chain 4 single bonded butane. Got it? So now write the name of complete, write the collective or complete name of molecule. 2-chloro 3-methyl butane. 2-chloro 3-methyl butane. Got it? The next one, that is here 3 carbons are in series and 2 chlorine are attached at second number carbon. That is chlorine. Okay. So 2 chlorine, that means dichloro. At which carbon? Second. So that is 2,2-dichloro. It is 2,2-dichloro. Now write the name of main chain. 3 carbon, prop, single bond, ane. So the name becomes 2,2-dichloropropane. Got it? Now this example. Here one substrate is chloro and one is bromo. So which comes alphabetically first? Bromo B. That's why the numbering is done from that side. So bromine is at second and chlorine is at third. Got it? Now write the name alphabetically. Bromo first. So bromo, which carbon it is attached? Second. So that is 2-bromo. That is 2-bromo. Got it? Now that is chlorine, which is attached at the third number, so that is 3-chloro. Now write the main chain. Bute, because of the 4 carbon, single bond in butane. Got it? Now this example. Here 5 carbons are in series and chloro and nitro. Chloro and nitro are substituents. Which come first? C, chloro C. That's why the numbering is done from that side. So it becomes 2-chloro 4-nitro pentane. Got it? So these are some examples of nomenclature of alkanes, IUPAC nomenclature of alkanes. Got it? Now let me start the second series, which is alkenes, or also called olefins. Alkenes or olefins. Alkenes, as we considered earlier in the previous videos, alkenes, that means those hydrocarbons in which double bond, minimum one double bond, minimum one double bond is present between carbon atoms is called alkenes. Got it? So we can say that these are hydrocarbons in which one or more double bonds are found between carbon atoms. These are hydrocarbons in which one or more double bonds are found between carbon atoms. Got it? These liquids give oily, these compounds gives oily liquid when they react with bromine water. When they react with bromine water, they gives oily liquid. That's why they are also called olefins. That's why these are also called olefins. Got it? Now their general formula, again it is very important. That is a frequent question of examiners. Write the general formula of alkenes. It is CnH2n. CnH2n, where N is denoting number of carbon atoms. N is denoting number of carbon atoms. Got it? And its numerical values will be 2, 3, 4, 5 and so on. One thing let me clear you. In alkanes, we start the value of N from 1. We start the value of N from 1 in alkanes. But here, it is start from 2. Why? Because for making a double bond, minimum 2 carbon is required. A single carbon atom cannot make double bond with other carbon. Minimum 2 carbon is required. That's why the value of N will be 2, 3, 4 and so on. Got it? That's why its first member is ethene. There is no methane. I am repeating, this is the most common error you normally did in the paper. Write the first member, then you write C1, that means methane. There is no methane, because for making double bond, minimum 2 carbon is required. So the first member is ethene. If we derive the molecular formula from this, for ethene, eth means N is 2. If we write the value of 2 here, then C, put the value 2 here, then it is C2, H2 into 2. So the formula becomes C2H4. In the propane, value of N is 3. When we put the value here, then it becomes C3H2N into 3. So that is C3H6. Similarly, butane, N is 4. Write the value here. Then the formula becomes C4H8. If we consider the pentene, N value, the value of N is 5 for pent. Pent, that is 5. So when we put the N here, then the formula becomes C5H2 into 5. So it is C5H10. Similarly, hexene, hex, that means N value of N is 6. The value of N is 6. Now put the value here, then C6H2 into 6, it becomes C6H12. Got it? So these are the first members of series of alkenes. Got it? I think, hope you understand it, enjoyed it. Okay, about the nomenclatures, rules and examples of nomenclature of alkenes we will discuss in next class. Okay, thank you.